Hi everyone, thank you for joining our OpenPlanetary virtual lunch talk today. Today we have Dr. Stephanie Jarmak. Dr. Stephanie is the project scientist for Planetary Science for the Astrophysics Data System and its expansion to the Science Explorer. In addition to her role as this project, Dr. Jarmak is also an active planetary science researcher studying asteroids with space telescopes, numerically modeling grain flow on planetary bodies, and studying planetary ring systems. She received her PhD in physics, planetary sciences from the University of Central Florida in 2020. Her master's in physics was from Texas A&M Commerce in 2015 and her bachelor degree in Earth, Atmospheric and Planetary Science from MIT in 2013. In today's talk, Stephanie Jam is going to talk all about the Science Explorer, which is funded by NASA. It expands the NASA Astrophysics Data System areas by integrating literature across astrophysics, planetary science, heliophysics, earth science, and biological and physical sciences. Utilizing advanced semantic techniques and knowledge graphs, SciX improves the discoverability of the Earth and space science research ecosystem, fostering innovative research and collaboration. Specific to planetary science, SciX plans to integrate with the solar system, open database network, SsODNet to tag planetary objects effectively. Ongoing efforts include using named entity recognition to tag planetary feature names and planetary missions in scholarly papers. Additionally, the development of an enhanced public library interface will enable more streamlined researching and sharing of libraries within the system. The SciX platform is continuing to grow through ongoing enhancements via machine learning and natural language processing, enhancing search capabilities and curation efforts to enhance the content accessible within the system. The SciX Ambassadors program enhances these initiatives, promoting open science and interdisciplinary collaboration across the communities the SciX supports. We are very happy to have you here, Jarmak, and please take the floor.
Okay, great. Thank you so much, Indu, for that introduction. So I also just want to thank the organizers and the OpenPlanetary community for giving me this opportunity to talk about the Science Explorer with you all today. And also just as a caveat, I tested positive for COVID this morning and I'm like not 100%. So I apologize if I might have brain fog and I can't answer some questions effectively, but you can I'll follow up by email afterwards if that's the case. But I'll just dive right into the talk now. So what this presentation is about, I'm going to be updating the OpenPlanetary community specifically about the expansion of the Astrophysics Data System to the Science Explorer, which is part of NASA's open source science initiative. I'll be highlighting in particular some of the progress we've made in expanding to planetary heliophysics and earth science content ingestion into this SciX platform, and showing how the system can already be used for discovery purposes, reporting, data stewardship, and some AI machine learning development. And I'll also highlight some of the challenges that we face during this effort and solicit some input and opportunities for collaboration and be advocating for this increased level of collaboration, in particular for assisting with data indexing purposes and linking to resources that are most valuable to the planetary community going forward. So just a little bit of history, right? SciX is built by the team that's behind the highly successful Astrophysics Data System, which has been serving the astronomy and astrophysics community for the past 30 years. It's known and loved by the astronomy community, and all so planetary scientists are sort of included partially in that, especially the planetary astronomers. But maybe if you're more on the geosciences part of planetary, perhaps you hadn't heard of the Astrophysics Data System. And so, but now we're expanding to include all of earth science and be complete in planetary science. So we're hoping to be able to much better serve the planetary community. But just as a little bit of extra history, the Astrophysics Data System has been connected with the Planetary Data System, which is the archive for all of the NASA-funded planetary data since the 90s. And this was when all of that data was on CD-ROMs. So it's, of course, a completely different data landscape now. But there has been this relationship between ADS and planetary community for many years, but now we're really trying to support that community even further. Just to give a breakdown of what the organizational structure looks like for SciX. One of the particular modifications to the team structure is this, we're bringing together disciplinary scientists. So previously there had been collaboration between there's a PI, program manager, a lead project scientist, and then there's a development team and a curation and gestion team. And all of these folks, they come from astronomy and astrophysics backgrounds. So some of the curation librarians and developers, tech leads and whatnot, they all have like PhDs in astronomy or astrophysics, a lot of them. So there's a lot of in-house expertise for astronomy, but in expanding to SciX, we want to bring in more expertise for the expansion communities that we are going to be supporting. And so there was an astrophysics project scientist that was hired last August, and her job is to not break ADS. So to make sure that all of the astronomers and planetary astronomers in the community are happy with this transition going forward. And then I was hired as the Planetary Science project scientist back in November 2023 to make sure that the needs of the planetary community are effectively communicated to the development of the platform. And we have also hired an earth science project scientist, Anna Kelbert, who will be joining the team at the end of August. And we're really excited about that collaboration, especially since earth science is such that very different from astronomy and in some aspects of planetary science, but there's lots of interdisciplinary opportunities for growth moving forward. And just to highlight some of the, use of the ADS by the astronomy community, it's really well loved and used by like everyone in astronomy. It's as well cited as the Hubble Space Telescope, and it's been a valuable part of that community since the early 90s. But through the open source science or open science initiative with NASA, the folks came to ADS and said, please put in a proposal to expand your amazing platform to now cover and unify all of the NASA Science Mission Directorate disciplines. And so that's what the team did. And SciX as a website was launched in beta in December 2023 at the 2023 AGU. And it's available now at sciexplorer.org. You could go on there and use it immediately. I've used it already to great effect in creating a bibliography for a paper that I have in press. It's on archive and it's been ingested into the system already. And I also used the author network really recently to find a collaborator for a research project that I'm trying to allocate some funds towards. So I just like found this person who works in a niche area of research, and I cold emailed them, and now we have a collaboration going. So it's actually really useful even for fostering collaborations among researchers. So I've been talking about this in the context of ADS, but maybe you don't know what the ADS is. So what is SciX? It's a literature-based open digital information system. So it's completely free to everyone to use. And it covers and unifies the research disciplines that are funded by the NASA Science Mission Directorate, which include, in addition to astrophysics, planetary science, heliophysics, earth science, and the NASA-funded research in biological and physical sciences. And this is, showing support for NASA's open science efforts, and it enables this interdisciplinary research and collaboration by now integrating all of these different disciplines under, one platform. Just to showcase what our curation model looks like and sort of what the content completeness looks like within the system. So we start for each of the disciplines that we're going to be supporting with this core collection, and then all of the journals that discipline uses, and try to be complete within the refereed literature. And then all of those, those papers within those journals, they have references and they have other papers citing those papers. And so then we try to be complete in all the paper citing and all of the references, so that we can be as complete in the sort of research ecosystem around the core papers in a particular discipline as much as possible. So we consider ourselves like 99% complete in metadata for astronomy, and 98% for heliophysics, 94% for planetary science, and earth science. We're still coming up to speed with ingesting all of that content. It's a lot more content, so around 87%. And we are hoping to get up to around 10 million records or so in earth science by the next AGU. So AGU 2024 is when we are hoping to take the beta label off of our system. So why the Science Explorer? So we have, the utility of it is we have all of this discipline-specific research that's aggregated, connected, and indexed for each of the NASA Science Mission Directorate disciplines. And then we have, facets on the left-hand side where you can use to further refine all of your search results, looking by publication, article type, or various, by institute and things like that. So you can go into the system and see what's available there to further refine your searches. We also implement relevant taxonomies to capture knowledge and semantics of subject disciplines. So you can see an example there. One of the new additions to SciX that's unique from ADS is this planetary feature option, where you can search by planetary feature name, or whenever you're looking at your search results, there's a planetary feature facet that will show you all of the associated named planetary features with each of those records. So you can narrow it down maybe by your favorite feature type or something like that. And this is utilizing some named entity recognition, because in planetary science, some of these names it's really difficult to disambiguate them. But we use the context around the specific name to be able to associate it with, okay, we see Cassini here, it's not talking about the spacecraft, it's actually talking about Cassini crater on Mars or something like that. And so we build out this sort of hierarchy of, okay, this is a name of a crater that's on a planetary body. So we're continuing to make that pipeline even more robust. And we also enrich all of our resources with data products, software, and notebooks, funding information, wherever they're available, wherever they're provided to us by the publisher, content. So if there's a data availability statement, then we parse the DOIs and whatnot in there to then associate the additional information with the literature, and we're trying our best to make the full research ecosystem around the particular record as discoverable and accessible as possible. And we also are working towards creating these discipline-specific capabilities relevant to the various research communities. So something new with SciX is we have this drop-down menu where you can select your specific discipline of choice. Right now, it's there's not much that changes when you do that. So the examples that you see on the landing page will change to be more relevant to the community. And for example, on the facets on the left-hand side, if you have astrophysics, then you see NED and Vizier catalogs, but those are hidden if you were to say identify yourself as an earth scientist or something like that. And if you select astrophysics as well, then you have access to the classic form, just to try to cater to some of our astronomers who are really don't want to let the older interface go. But we are working towards trying to be sensitive to not siloing the disciplines, but trying to implement features that are most beneficial to the disciplines. So the planetary named features and things like that, and trying to integrate certain expectations about nomenclature and things like that. When somebody comes to the search bar, if they are identifying themselves as a certain discipline, how are we interpreting what those queries are in the context of that discipline, while not siloing the actual disciplines from one another, because we want to protect the interdisciplinary nature of the system and make sure everything is still fully discoverable. And we also have these ongoing initiatives and collaborations across many different organizations, one of which was a collaboration with IBM and NASA to create this large language model that was trained on our really well-labeled scientific corpus. So we have lots of exciting machine learning sort of project collaborations ongoing as well. So some more, how is SciX different from ADS? So it's built on the same database and API, but there are improvements. So if you were to be using ADS, you are accessing the same multidisciplinary corpus as SciX currently, but the UI and website have been improved for accessibility and usability to meet modern standards. And there's some better handling of filters. So when you do the author search, that's one of the sticking points that we have. We're trying to figure out the best way to allow users to disambiguate when they're searching on authors, particularly with common names. But so we've improved some of that filtering capability in SciX. And there are some UI enhancements and discipline-specific ones. So the planetary features facet is only available on SciX. There's also improved ORCID integration. And if you're not familiar, but you probably all are, but it's the Open Researcher Contributor ID. And so we really encourage all researchers to get one of these unique identifiers. And we make it really easy for you to log into your ORCID and be able to, if you search for your papers in the system, there's a claim to ORCID button that shows up for each record. So you can just automatically be adding your papers to your ORCID to keep your ORCID profile as up to date as possible. And it's one of the best ways to disambiguate authors in the system, because you can also search by ORCID number to be able to bring up all of a author's specific works. And another difference is that the default for the search ranking is now relevance. In ADS, it was date. You can always change it back to date if you prefer that, or there's by citation count, and then we have various ways of ranking that. And we're working on making that relevance algorithm as robust as possible now that we are modifying the content of the corpus quite significantly and moving away from purely an astrophysics collection. And so we're working on potentially modifying this to be more discipline specific or user profile specific, but that's an ongoing technological effort. So what can it do? You can use SciX to search literature by topic, so putting in just phrases relevant to what you're looking for, keywords. You can search by authors, so people, looking for specific authors by author position as well, so first author, last author. Organizations, so you can search by institute or affiliation, which is of particular value if you want to maybe chart the impact of a particular institute over time, or if you want to further disambiguate an author, this particular author is working at Southwest Research Institute or something like that. And by objects as well, which is most relevant currently for astrophysical objects, but we are working to integrate the Solar System Open Database Network, because they have that with their API, they have a capability for us to integrate with them to be able to better tag our literature records with all the planetary objects. So we're working to expand the object search to our other disciplines as well. And for any set of papers in the system, you can go click explore and visualize, and you can visualize all these different relationships between the records. So you can look at metrics, so see how well it's cited or how well it's read. Collaborations, so you can click on author networks to see these different groups of authors, and you can overlay that to see how authors work across various collaborations. And those collaborations are identified based off of similarities in the citations across all of their different papers. And by topic, so you can create this word cloud associated with your returned search results, and you can click on the keywords in there to further refine your search results. Analytics as well, so you can see how the citation count changes over time and things like that, which is particularly useful for any sort of reporting mechanisms. And you can, I think many people don't know this, even if you've been using the ADS, but there are these second order operators, so unique ways to work within the paper network. So you can find, for example, review papers using the reviews operator. And so you use reviews and then put in your keywords that you want to be searching on, and that will, say if you put in exoplanet atmosphere, you'll get relevant results for exoplanet atmosphere. What reviews does is returns all the papers that have the most references that are most similar to those relevant results. So you're most likely to get the papers that are referencing all of these, all the trending papers within that particular topic. You can find articles with data, so we could put data and then the archive name if you're looking for articles that are associated with a particular archive, or you could do property data if you just want any enriched literature in particular. You can search by institutions, looking for particular affiliations, which, as I mentioned before, is useful for disambiguating authors or for generating impact for particular institutions. You can search by the ORCID to be purely disambiguating the authors and look up a specific researcher's works. And you can also find funded work. So this is particularly useful for funders and things like that. So searching by acknowledgement or affiliation as well. And then, so say you put in your query, you get your search results, you see a title or record that looks interesting to you, you click on it, this is what you would see. You'd get to the abstract landing page, and from that, you'd be able to access any of the open access versions. So it's not really visible here, but wherever there's an associated like preprint version or open access version, that's made discoverable to folks. Any of the citations or references, similar papers, if there's an associated data product or a software product, and it's under other resources, and then it'll list out the name of that product as well. And here's an example, just going through an example search that somebody might do. So if you just were to, maybe you're looking up everything about the Saturn mission Cassini. So if you typed in just Cassini Saturn into the search bar with no other like filters or anything like that, you get around 8,600 results sorted by relevance. And then you could use the GUI slider on the left-hand side to maybe you wanted to restrict it to like the mission lifetime, then that would further refine it to 7,800. That's still quite a lot of papers. But maybe you're interested only in these records that are associated or have an associated data product. Then you would add property data, and then that gets you, okay, now 260, that's like more workable for further filtering. And then let's say you want to identify what some of the collaboration groups look like in the author network. For that, and you could see that the system identified these like 7 collaboration groups. And if you select one, you could see all the papers associated with that particular collaboration group. Then you can choose you can change how you sort what those results look like. So here it's sorted by citation count. You could also return the results as a word cloud. So searching on Cassini Saturn, you see all of these different keywords associated with it. So let's say we wanted to look at all of these results within that group that had plasma associated with it. And you see there's 33 papers that have plasma associated with them. And you can also go into the left-hand side in the data drop down to filter by a particular archive. So let's say you wanted to limit it to the Planetary Data System. So you see 9 of these have PDS data, and you click on an article and click on the other resources, select the PDS link, and that would take you to the link associated with that data product. And some of the other utility of the system is that you can get the data behind some of these visualizations and different outputs. You can get CSVs for all of the different metrics that you're generating for particular search results, which is particularly useful for reporting. And if you wanted to visualize it in a different way, you have like the raw data behind it. As well as being able to export bibliographies. So that's something I did recently. I made a personal library with all the papers associated with the paper that I was writing, which was just useful anyway to have access to refer back to in the writing process. And then I just exported it in BibTeX and added it to my LaTeX file, and it was just like very simple and easy and saved me a lot of time. So there's lots of different formats and ways to do that, and exporting citations for various articles. And there's also access to the API. So currently it's like the same as it's basically the ADS API still. So it hasn't really been modified in terms of even like the URL that you're accessing, but it's still, you're accessing the multidisciplinary corpus that's associated with SciX. And we have many help pages and documentation on using that system to be able to automate certain processes. And we've also started to put together like a little GPT chatbot as well that will enable users to sort of chat with the API documentation, particularly for users who aren't as technically savvy, just to help them out so they can use natural language and asking, I want to be able to set up a query to automate this output. Then you get the full syntax that way. This is just a sort of high-level overview of what our development and operation plans are. So we are working towards author disambiguation, improving our search infrastructure, improving our text mining capabilities and citation processing, and our metadata enrichment pipelines. And we are, working on expanding our ingestion of the content, making useful updates to the user interface, improving our user support, interoperability with various research systems, including archives, data centers, and collaborating with publishers and data providers, publishers in particular, to get access to some of their unique metadata and full text wherever we can, sort of negotiate that, and maintaining this growing complex system infrastructure. And we are investing heavily and utilizing machine learning capabilities and building out these disciplinary teams so that we can achieve the goals of our system expansion. And there is a certain commonalities, sort of like discipline agnostic aspects of the system expansion. So we do the census of literature and its links to the research data ecosystem. So going to the repositories and identifying, do they have the DOIs of the papers and the associated DOIs of the data products that they can provide to us so that we can sort of build out those links already, and what resources can we provide to them to help them build up those relationships and maintain bibliographies and things like that. Harvesting and adjusting the metadata for refereed literature, and then later gray literature, which is much more difficult. So gray literature being the unrefereed, like thesis, workshop reports, white papers, and things like that. Doing the citation and full text processing by text mining. And as I mentioned before, the creation of these bibliographies, and that's where we're working with various archives like telescope centers, and now we're trying to expand that to missions as well, and various databases to help them use our tools to maintain their bibliographies, which improves the discoverability on their side, and we're also improving the content of our system. The extraction of these data links from research repositories to be able to link them. So getting that from the full text, typically of the paper, if we're not getting it directly from the research archives. Doing some enrichment of the metadata with named entity recognition. So that machine learning that I talked about before, using the context around particular entities. So we talked about planetary features, so we're also going to be expanding that to say like missions, planetary missions, other missions, instruments, and other named entities of interest to our various communities. Integrating these discipline-specific taxonomies for tagging and indexing, for example, utilizing the Unified Astronomical Thesaurus, which will help us with, in particular, astrophysics, planetary, and helio, but trying to identify ways to incorporate those taxonomies across our other disciplines as well. And integrating API services from various collaborators, like I had mentioned, the Solar System Open Database Network. So working with those groups to be able to enrich the content of the metadata in the records that we have. In addition to that, for like earth science, we're looking into other enrichment activities like geolocation tagging, which is an ongoing effort. And just to explain a difference between when we link to data products versus index them. So what we're indexing in the system are, the content that is searchable as like you get an abstract sort of landing page. It's the scholarly literature that's of interest to the NASA SMD discipline researchers, which is, the literature, and also peer-reviewed catalogs or observing and funding proposals, and data and software products that are cited by DOI. So that's kind of the criteria for us to index it. It has to be cited. But if a particular record happens to mention that it used a particular data product and has a DOI or whatnot associated with it, then we will link out to that resource as a associated product for that record. Or yeah, so it's not necessarily going to be searchable unless it is actually cited by the record. And just want to point out that it's, really best practice to do your best to make your data available and discoverable. Assign it a DOI, put it on Zenodo or the PDS. I know it's a lot more difficult to get onto the PDS, but data usage. Well-linked papers receive more citations, so the data will be more heavily reused. It's just best for reproducibility for science, and your research will be more utilized if you are doing your best to associate the paper with the data. And as I had mentioned before, one of the benefits of the system is through reporting. So you get these metrics output. So you could think about that reporting benefit. There's different levels of granularity. So even at the individual researcher level, you can be able to, show this for like promotion purposes and say, hey, look how much I've been producing for this institute. Or maybe you're an administrator and you want to show the growth in a certain area for your institute. And so we're also working on discipline-specific collections. So that was something we had talked some folks at the JPL library about, where they're interested in not just looking at the expansion of their output overall, but looking at how that is as a function of various disciplines. And so that's something we're actively working towards. By improving these data links and indexing them in the system, it's improving the system itself and also exposure of these different agencies and institutes and facilities that are producing the data. So we want to help folks maintain these meaningful bibliographies. So we've been reaching out to folks who are leading these missions and part of these projects because we really want to make that as discoverable as possible in the system. And we're also working to better implement the discoverability, say, of public libraries within the system. And so that's something we're actively working on. And so some of the data linkages, they can be mined out of the current publications, and we do that wherever possible, but a lot of it is missed, and all of it requires curation. So there's this ongoing relationship that needs to happen between SciX and the various projects and data archives. And as I mentioned before, linked data is more heavily reused, and we provide this infrastructure to easily maintain and index these bibliographies. And we have all of the major astrophysics archives participating. We really want to encourage more active participation from the disciplines that we are expanding into, which includes planetary science. And this is sort of like the workflow of how it all goes together in terms of like being a maintainer, say, of a bibliography. So you use SciX to search for papers related to the bibliography that you're maintaining, using a lot of these built-in features. So you can narrow it down by affiliation, or if it has links to particular data. This is something that you can, that would then add it to a bibliography. And then you can set up workflows to automate the process. So you could use our API to do that, or you could set up my ADS notifications to alert you to the new additions in the corpus as for a particular query, and then that's shared back with us in terms of sharing this bibliography and data collection, and then we can make that available to the SciX users. And we also are always encouraging feedback to the staff about any missing content or features of interest that the community would benefit from. And so what we're looking for in terms of like involvement, ways to improve the semantics for especially the new disciplines that are being covered by SciX, which includes planetary science. I am an active planetary science researcher, but I can't possibly represent the entire breadth of the planetary science community. So working with folks across the community to make sure that we are meeting their needs and testing maybe early prototypes with scientists across the disciplines. And we want to make sure that all of the citable data and software is represented in SciX. So making sure that these our links are available. So alerting us if we should be considering these other archives to talk to, or different ways to link together the literature with the data. And we want to make sure that our named entity recognition projects are useful to the research community. And we have this labeled data set, so there could be collaboration opportunities as well for considering projects that would use the data set that's really valuable within SciX. We also have an ambassador program. So we had recently selected 12 lead ambassadors across the various disciplines. We have 3 of them in planetary science, and they're actually going to be coming to the CFA next week for a workshop where we're all going to work together to come up with strategies to best communicate SciX to these various expansion communities, we're trying to build up a more general ambassador program and engage this sort of network of networks to build an interdisciplinary community around SciX. And yeah, so I can take any questions about the platform, and the QR code there takes you to our link tree, which is just a variety of links, including some of our like quick start guides and where we are in social media. And if you have any further thoughts about this or want to reach out to me to collaborate or just chat about anything, my inbox is always open and my email is right there. So thank you.
Thank you, Stephanie, for this amazing talk about and all the introduction and things and all the things goes into the Science Explorer. It was very helpful. Next, we have the Q&A session. So I'll stop recording now so that we can interact with Stephanie.